the reason that gold doesn't work over time is, by the way, we have two examples. It doesn't work over time because people produce 2 to 3% more of it a year. And over 100 years, that means you lose 90% of your energy. It doesn't work over time because there's counterparty risks, and the Polish bank, through no fault of their own, got overrun by the Nazis in World War II. And the Beijing bank got overrun by first, one regime, then another regime, then a third regime, right? So that's another reason it doesn't work. And the third reason it doesn't work is if the people become threatened by the network. So, for example, 1933, Franklin Delano Roosevelt found gold to be inconvenient. If the people become threatened, they complain to the politicians. The politicians might go ahead and take action. And in this case, the reason that they were able to take action is because all the gold was sitting in the same place. So if the gold's sitting in a vault and we know where it is and it's under the control of institutions, the institutions are under control of governments, and therefore that heightens the counterparty risk because of the centralized nature of gold. So the best case for a gold network is you're going to lose 90% of your energy over 100 years. But the likely case is you're going to lose 95 to 98% of your energy over 100 years. And if we looked at Nicholas Taleb's range of outcomes, if you take the 100 biggest cities in the world, and you put your gold in the best bank in any of the 100 cities in the world, it looks like in 95 of them or 96 of them, or maybe 99 of them, you lost all your money. You lost all your So isn't it, if we come back to the issue of monetary, now, go ahead, Robert.
Just add one thing. So that highlights to one of the shortcomings of gold is that the economies of scale lead to its centralization, right? Because it is so heavy and hard to transact, it's not, you compare it to Bitcoin that's non-corporeal, that can be transmitted at the speed of light. Because gold is so heavy to settle, right? That leads to its centralization in bank vaults, and that becomes the ultimate honeypot for politicians and governments, frankly. And the other, I guess, attack vector we didn't discuss is that temptation is always given into, right? As soon as things get dicey, governments immediately monopolize that golden energy network, which is the most important in the world.
Let's say it's not fast enough. We talk about, every good technology is smarter, faster, stronger. Every technology, smarter, faster, stronger. So coming to digital gold versus gold, physical gold is not fast enough. How fast is it? If I wanted to move $100 million of gold, as we talked about, it's going to cost me $250,000. So it's impedance. But how long is it going to take you? A week? A month? Somewhere between, you want to move 3,000 pounds of gold from New York to, I bet, a month. I'm guessing, if you want to get all the protocols set up. So you're talking about $250,000 in a month to move the gold. If, assuming I needed another custodian and I used Bitcoin and I wanted to move $100 million of Bitcoin, and this is where, Bitcoin critics are just utterly wrong and missing the point. They all think, oh, well, it takes 30 minutes and $5 to move Bitcoin. And they're comparing it to a new crypto network that has no value on it. And they're saying, I can find a way to move it in 5 minutes for a nickel. But that's not the point. The appropriate comparison is to gold. How long would it take to move $100 million of gold? And because there's $250 trillion in assets in the alt assets, and there's only $25 billion of real asset in the alt coins or the alt cryptos. So how long does it take me to move the $250 trillion around? And when you think about that, you realize that Bitcoin would move it in 30 minutes instead of 30 days.
Mm-hmm.
Okay, that's 1,440 times as fast, right? 1,000 times as fast a minute versus 1,440 minutes in a day. And so it's 1,000 times as fast, but then it's $5 versus $250,000.
Right.
I know. So we do that. That's 50,000 times cheaper.
Absolutely.
So now we've got people saying, "Oh, well, it's very energy inefficient." Blah blah blah. Well, it's not really. It's inefficient in the way that it's inefficient to create an electro high speed transit system, a mass transit system. It was expensive to build the mass transit system. It got really, really cheap to move on the rails.
Right.
If you look at the history of railroads, right, the biggest thing in the 19th century was railroads. It was pretty expensive to create the railroads. It became really cheap to move on the rails.
Right.
So what we do is we've created crypto rails in order to make it 50,000 times cheaper to move. But it's not just that it's 50,000 times cheaper. It's that it's 1,000 times faster and 50,000 times cheaper. And then when you start to multiply 1,000 times 50,000, and you realize it starts to be 50 million times faster. Right. And then you start to add that third dimension, which is maybe a computer that thinks about this while you're sleeping 18,000 times. And you realize eventually you get to 50 billion times faster. And now we've got to a new engineering or our new scientific metaphor, which is superconducting networks. Right, okay, right. If you know, there's impedance going through electric power network and you're losing it. And so the solution is I need to get to superconductance. I got to cool the network down to close to near zero.
Right.
And it's expensive. And the point is, yeah, it's expensive to get to near zero. And then the impedance disappears in the network and the friction goes away. And what could you do if the friction went completely away?
Right. You're in outer space, right? The smallest amount of energy can move something billions of miles. And I love that analogy too, that you're getting to a lower energy state and that eliminates the frictions to conductance. So you achieve superconductivity. And in a way, that's what Bitcoin is, right? It's a monetary medium completely free of the noise of unexpected inflation. So you're actually conveying pure price signal. Something even gold, we didn't quite have that.
And I love your analogy because, I mean, the aerospace engineer in me is loving it a lot. You could think about when you encrypt monetary energy on the Bitcoin network, it's like achieving escape velocity out of the gravity well. What we've done, we paid a price to get out of the gravity well, throw a baseball on a baseball field that goes a couple of 100 feet. Get out of the gravity well, throw the baseball, it'll go around the earth forever.
Yeah.
Doesn't it? Okay, so how much more distance do you get out of the baseball if you pay the price of getting out of the gravity well?
Right.
It's not like 10 times better. It's not 100 times better. It's not 1,000,000 times better. It goes to infinity and it never stops. And that's the breakthrough that people don't get. It's like, what could I do if I had vacuum and I was rid of friction? And yeah, there's a price to pay. And that's your phase change and your state change. And that's why I would say Bitcoin is the most efficient system for channeling energy through time and space in the history of mankind. We've never figured out how to channel energy with no impedance and channel energy with no loss. But let's come back to the outer space analogy. Take your flashlight and shine it in your basement. Take your flashlight, shine it, on your baseball field. Now get into outer space and take your flashlight and shine it. Or flip it the other way, the Hubble telescope, right? How much better are the photos you get from the Hubble telescope than the photos you get from a telescope that has to shoot through the atmosphere?
Right.
It's
Free
not
of
like
distortion.
It's a billion times better.
Yeah.
It's like you just can't really imagine the world when you're trapped in this energy well.
This analogy too holds for the counterparty, the institutional counterparty risk. It's almost as once you escape the gravity well, you're also free of institutional counterparty risk, right? I don't need to worry about the stability of the United States or JP Morgan to transmit Bitcoin 100 years into the future. You only need to be concerned about the stability of the energy network, which is maintained by the collective self-interest of the world, in theory.
Yeah, it's something that's just altogether unique, and we've just never had it before. If you now conceptualize that and you go through your thought experiment, you realize we need a monetary system, and our monetary system, the three in front of our face, are let's take it. Fiat as a monetary system, gold as a monetary system, Bitcoin as a monetary system. If I put my $100 million of monetary energy, I have energy. I take energy, I sell it on the grid, you give me money. I take my money, I put it into the US dollar bank, it's in fiat. I wait 100 years. And it's 7 to 8% asset inflation rate. I have a half-life of 10 years. So I get cut in half 10 times. Okay, 100 million, 50 million, 25 million, 12 million. It's going to get painful. Yeah. 6 million, 3 million. I only cut in half 5 times. 1.5 million. That's 6 times. Now it gets really painful. 70 basis points, 35 basis points, 17 basis points, 8 basis points.
8 basis points. Crazy.
By the way, 8 basis points if you don't get hyperinflation. The 8 basis points if your nation wins.
Your best case. Yeah.
Your bet, So we're not even want to say you're losing 99% of your energy is being charitable. 99% of your energy, let's say. Now let's put that, let's generate $100 million worth of electricity by burning coal or nuclear power or pedaling on my flywheel or rowing on my rowing machine. However you got to it, windmills, let's sell it to the grid, take the 100 million, and let's go to JP Morgan and let's buy $100 million worth of gold and let's have them custodian for me. Put it in their vault. I guess I could just take it with me. It's 3,000 pounds. Right, $2,000 an ounce or whatever the number is, Yeah. Okay, so 1.5 tons. No, I got to put it in a vault, right? So I put it in a vault, and I pay for custody fees, and going in there's a fee, and then I'm paying whatever 20, 30, 40 basis points a year to keep it. And then the miners are out there doing their mining thing, and it's probably 200 basis points worth of additional gold. So that's 250 basis points a year. And if I watch it and, assuming it's just a dead rock and I'm not, it's heavy, I'm not moving it, I'm doing nothing with it, I'm just staring at it. Then I've got to add on the counterparty risk and then the fracking risk or the technology risk.